Okay, Luke, we're back. We seem to be back in a very different world to the one we were in a few weeks ago. So we're now have moved from being able to work at university to working at home. And of course, my home is some sort of post-apocalyptic bunker that I've hunkered down in. So we can't do our normal recording of Alas, but we'll give it a go from our homes.
Yep, let's do it.
So yeah, so let's start nice and easy and move gently into things here, and just deal with a little physics concept we've discussed an awful lot over the years. What is time?
What is time? There's a classic quote that everyone starts off any discussion of this is. You'll see all over the place. We put it in our book in A Fortunate Universe, and it's everywhere. It's from the Confessions of St. Augustine in 400 AD. And he basically says, look, what is time? If no one asks me, I know exactly what time is. And as soon as you ask me, I don't know. Which sums things up pretty well. In physics, here's a starting point. In physics, I remember my special relativity lecturer, who was Tim Betting, basically said, what is time? And then he wrote the definition on the board. For a physicist, time is something you measure with a clock. And that's, there's a starting point. If you just want to start there, you can just say time is whatever it is with a clock. But, we have, as well as that, we have this, we have all the commonsensical notions of time, that it flows, that there's this thing called the present, which is here now. The future hasn't arrived yet and the past has already happened. Time affects causes. So causes happen before their effects, or at least maybe at the same time as. We have memories of the past, but we don't have memories of the future. We can control what happens in the future. We can't control the past. There's all these sorts of things. But to a physicist, time is this variable t. For a theoretical physicist, there's this thing called t that we're always talking about.
So I remember thinking back to when I first learned physics, and time is a given, right? I mean, you start off by doing your Newtonian mechanics, and you talk about an object's location in space, and so you have to have some coordinates to say where an object is, and you talk about when an object is, and so there's this time. And when you develop your equations that you work with in physics, it's how things change with this thing called time. And as you said, time is the thing that a physicist measures on a clock. But when you talk to people, they always want a deeper answer. Like, time is, and I'm not 100% sure what kind of answer would satisfy them, but what has happened, of course, over the last more than just over 100 years now is that the notion of time has evolved from what Newton laid down when he spoke about classical mechanics into a much more complex kind of thing. So maybe we should start with what Newton thought about time.
So what Newton says about time is that time is absolute. He thought space was absolute as well, which what he meant was, regardless of what you're doing, time is just this thing that ticks away through the universe. There's some sort of dimension of our universe, and the assumption behind that, which is almost goes unstated because it's too obvious, is that everyone's going to agree when now is. So if I've got a clock here and there's another clock over there, whatever is ticking away on my clock, whatever sort of dial I've got here, and whatever sort of dial's over there, there's some relationship between them. We can all decide when there's some now when I could say this clock is at the same time, that this tick of this clock is the same time that happened over there. So for Newton, that was sort of almost too obvious to state, but he lays it down because he's trying to go from the basics. But that's Newton's absolute time. Everyone agrees on what time now is, and everyone agrees on how fast all clocks are ticking, and all of that, is all sort of taken for granted. Like, when he said that, no one really argued back against him.
I have a story that might be slightly apocryphal, but apparently, even though Newton said this about time, that's not the way that time was actually kept in the country. I mean, what you referred to is your local clock in your local village, right?
Yeah.
So and people would set the clock by definition of midday, which is when the sun reaches the highest point. So different villages would have different times based upon, how far they are east or west, because that dictates when the sun is at this highest point. And it wasn't until the coming of the railways, where people needed accurate timetables,
Right.
was a uniform time spread across a particular country. So, even though Newton thought that way, that wasn't the way the time operated on a day-to-day basis.
Yeah.
But
sorry, go on.
No. Over to you.
One of the things we think about time, one of the most basic things is we think time flows. We all think that, if I just give it 5 seconds and 5 seconds into the future, we'll be here. Like there's just, I experience one moment after another. But when you're a physicist, you know what the flow of time means. You know what a flow is, sorry.
Right.
Like that's when something changes with time. Like, the water in a river goes past. But time flowing in and of itself doesn't actually make any sense. Like, what is it flowing with respect to? Like, what's its, at what rate? It's going 1 second per second. So, again, this is one of those notions where you've got you've got your intuitive thing of, we all know what time is. And then once you start to look at it in a bit more detail, it starts to become more confusing.
And of course, the real spanner in the works for time, I think, started when, the end of the 1800s and into the early 1900s, and especially with the arrival of the special theory of relativity. Mm-hmm. And of course, the story is that Einstein had this equivalence picture, basically, if you're, that there's no absolute at rest in the universe, and anybody moving with respect to anybody else, the laws of physics that they do should give the same answers. Mm-hmm. And to make that work for electromagnetism, what you had to do is, if you wanted Maxwell's equations of electromagnetism to work here and also in a train which is moving with respect to you, the same equations, then space and time have to give. They can't be absolute rigid concepts anymore. They have to vary depending upon who the observer is. Mm-hmm. So then the notion of time as this rigid thing set throughout the universe sort of goes out the window. So you then have this more complicated thing of that time is something that's experienced by something mm-hmm. moving through this larger thing called space-time.
So one way of thinking about this is to think about all the different places in the universe and all the different times in the universe and just sort of map them all out. Okay. And so you can think of like a two-dimensional. So in relativity, for some reason, we put time on the vertical axis. So here's, let sort of the screen here be all the place and time. So here's, 2 a.m. over that way. This is one dimension of space, of course, unfortunately. But, and so the question is, okay, here's all of the times and places. Is there anything that actually corresponds to the idea of the same time at all different places? Now, we can think of, when you're a physicist, you try to think of an experiment that you could do to work that out. And you can think about bouncing light rays around. So, for example, if there's a place over there and I bounce a light ray off and I've got my clock here and it takes a second to come back and then I do it again and it takes a second to come back and I do it again. Okay, that's 1 light second away. That person over there, they're not moving. Okay, I've got that down. Then you think, okay, when is now for that person over there? Suppose they've got their clock. How do I line up the two clocks? Well, you could think of, I throw my light ray over there and it comes back. And when the light ray reaches them, I think about it's sort of halfway in the distance. So I think about half the amount of time that it took to come back to me. And then I say, that event over there, they got hit by a light ray, is the same time as me over here, halfway between sending and receiving the light. And that all sounds perfectly reasonable. The problem is, once you've done that, and as you said, electromagnetism, and particularly once Einstein taught us how to do electromagnetism properly, if you want to put it that way, in special relativity, the problem with that idea of how I'm going to define when now is in the universe is if someone over there is moving with respect to me, and I can work that out again with my little clock. I bounce a light ray off them and it takes a second, and then I bounce another one off them and it takes a second and a half, and then I bounce another one and it takes 2 seconds. Okay, they must be moving away from me. When that person does the same sort of map of their universe to work out what's all at the same time, they don't agree with me with my map of the universe. So there's two events. I say this event and that event, they happened at the same time, but that person over there, they say, no, they didn't happen. One happened earlier than the other one. And so suddenly everyone moving in the universe, we never notice it in everyday life, but if they went and mapped out the universe in this way, they would find out that they don't agree on what events are happening now.
Yeah. So in answering the question, then what is time? We've just made it a whole lot more complicated, right? I mean, it was difficult to answer in Newton's picture, and now it's even more complex because it depends upon what an individual observer is doing. And of course, observer here could be anything, right? It's not just a conscious being.
Yeah.
Anything that's moving in the universe, it has its own internal clock, and that internal clock, it might be a particle that decays, and its internal clock ticks away with what we call the proper time, the time it experiences along its path. But that time, the duration that particle experiences, will be different to a different observer who's at rest or moving in a different kind of way with regards to that particle.
Right.
So yeah, time is now this thing that seems to be attached to individual things moving through space-time. So you have this concept of proper time.
Yeah. So over on the other side of this picture, there's also there's a whole bunch of philosophers thinking about time as well. Starting with at least Augustine, if not Aristotle, and obviously time's something to think about. So philosophers love anything where the harder you think about it, the harder the problem it seems to be. So time is that sort of thing. There's a nice distinction made by a philosopher called John McTaggart in about 1908, so about the same time that Einstein's doing his thing. So it's the difference between, now the terminology here is not particularly useful, but he says there are A properties of time. So there's a fact about whether something is past or present or future. And there's what are called B relations between two times, of there being one time is earlier than, or they are simultaneous with each other, or they are later than each other. So the two schools of thought here you call it an A theorist or a B theorist of time when you're in philosophy. And it's a question of whether there are any actual A properties at all, whether there is such a thing as the now, such a thing as the future, such a thing as the past, right? Whether there is a fact about, what time it is now, or whether there are only the B relations. There's only a fact that there are some moments in time which are future to me here, talking here now, and some which are earlier than me now. So there's the A theorists who think there is something real about the now. So when I use tenses, future and past and present, I'm actually saying something about, reality as a whole, not just the relationship between two times. Or there's the B theorists, and the way I remember this is B for block. So where all times are equally sort of real, and the only thing that the future and the past is just a relationship between two times. And one of those times is usually when the person is speaking, right? So the future is just the future of me here speaking now, rather than there's anything real going on. So that sort of, there's actually some really interesting discussions there. So I've said to you before, the problem with the philosophy of physics is you need a good dealer. You need someone to find the good stuff. And some of this stuff is actually pretty good. But at the same time, into that comes Einstein, who says, okay, if you think there's something called the now, if you're an A theorist and you think that there is something real called the now, you're going to have to tell me what on earth that means in the context of what I've discovered about space and time themselves. And so, and, there's, people have thought about this for the last 100 years, of course. And I think that the main thing that's been decided from, if you're an atheist now, even if you're, you understand Einstein, if you think there's a real now, it's just, it has to be something else other than special relativity. There's got to be some other structure out there that special relativity just doesn't quite describe.
Yes. I've sat through a few philosophy of time talks, and every single one of them I come away thoroughly confused. So, but yeah, let's get back quickly to Einstein, because we do run into the notion of course, after the special theory comes the general theory, which is about, now there are other things that influence the passage of time. It's not just how you're moving, it's where you are in an expanding universe, where you are with respect to gravitational fields, etc. So you still have this concept of proper time, which winds its way through the universe, and you can talk about the experience of time, but the time for observers is very different depending upon what's going on for a particular person, right, or particle. And of course, we run into this picture of let's take our universe as an example. We can write down the equations of general relativity to describe our universe, and those equations tell us that we start in a Big Bang. The universe is going to evolve into the future, and there is a thing in there called the universal coordinate, time coordinate, right? So we have a big T, which is the time of the universe. But when we want to use the notions of time, we have to talk about the time experienced by a particle or somebody tracing their path through space-time, and that's their thing called their world line that traces its way through. And if we take it at face value, we can write down the entire history of the universe in terms of the mathematics, from the past, where the Big Bang was, all the way into the infinite future, and you or I will trace out our worm line. I'm going to use that as a new phrase now.
We've coined it.
Yeah, all the way along, and we can put a dot there, which is my now. It is now 9:38 and 47 seconds on the 1st of April. That's that point. But in this picture of the universe, my world line is already drawn, right? My world line basically traces its way into the future. It will be influenced by gravitational fields, etc. It will move around, blah, 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 blah. So my world line exists from here all the way to the distant future, which suggests that my future is already written, right? Not just my future, of course, everybody's future. In this picture, everyone's world lines are coming up from the past all the way into the future, and we've all got our nows, which are these points, but our world lines stretch into the future. And of course, this brings us into that topic that is beloved by philosophers and hated by physicists, and this notion of free will, right? If my universe is this block of space-time and I'm just journeying through, where is my free will? Where is my ability to make decisions that are going to influence my future? Over to you as a philosopher.
Yeah, let me just solve this problem once and for all. Yeah, so this is the sort of the B theory of time. So there's no such thing as the now. So in terms of like whatever you think, and physicists get worried by this word, real. What's real? What's really, really real? And you just got to shake your hands like that. That's very important. Whatever you think, whatever you think real means, if you're a B theorist, all times and places in the universe are equally real. Like whatever it means to be real, they've all got it the same way. And so, whereas if you're an atheist, you think, no, there's something different about the way that the present is real. And you might think the past is, depends who you talk to. Actually, George Ellis, who's a famous cosmologist, thinks like this: the past and the present are equally real, but the future is not. But if
I heard that statement, and then I go, "What the hell does that mean?"
Yeah, the problem is the word. Like when you try to understand a word, you want to sort of put other words around it to get a hold of it. But once you get down to the basic level of this sort of level. Like real, what do you mean by real? Like what other words could I can say, existing or being or something like that, but it's not like, oh, it's, made of sand or something.
Yes. Which is what I think people would like us to say when
Yeah.
I think if they said to us, "Oh, what is time?" and we said, "Oh, it's made of something like sand," they'd probably go, "Oh yeah, that's okay. I can do that."
I say that, but there's a dreadful cosmology book which I'll name it in the comments if someone wants to ask me, which has this notion of what happened before the Big Bang. Oh, maybe space and time were like little particles of sand floating around and combining, and then at some point they hit a combination that worked, and then there was space and time, and that was the universe. That is just the dumbest idea. I mean, what are they moving through anyway? Yeah, but this is a really hard topic to think about. So the thing about free will is, one of the problems here is you've got to have space in your picture of the world for there to be scientists. Right? Otherwise, you're in real trouble. And so there's a worry that if the whole future is mapped out in entirely physical, cause this and that and the other, then me deciding, I think that that I have reached certain conclusions about the way the universe works by looking at the evidence and thinking about the evidence, and we all work together and we design these experiments and stuff. And it's hard to think, if that was just stuff playing out and it's all mapped out. So what I conclude about some physical theory I'm thinking about tomorrow is already mapped out ahead of time entirely in terms of physical causes. There's a worry there that you don't your physical universe is fine. The only thing it can't have is a scientist who can actually think. And that's a worry, and I'm not entirely sure what to think about that. But this free will problem, it might seem like an abstract philosophical thing, except that you possibly need something like being able to think freely to be able to think rationally.
Yeah, I mean, I think people have proposed ideas, right? There's this notion that the universe is basically continuously unfolding or building itself into the future. There's a terrible movie called is it the Langoliers? A Stephen King book?
Oh, that rings a bell. Yeah.
It's about these monsters that eat the past. The reason that the past doesn't exist is that there's these creatures that eat the past. So there are people that have this.
Fantastic.
It's absolutely terrible movie. But the way this lockdown is going, I'm going to be watching it very soon.
Yeah, sure. We're getting in the deepest depths of Netflix as we speak.
There's this idea that the universe is sort of doing the inverse. It's sort of building itself into the future. That the universe of the future is yet to be written, but it will emerge somehow into the future, and that something that's missing is somehow written in the crossover between general relativity, describing the large-scale universe, and quantum mechanics, maybe build in space and time as we go. So maybe that's where free will is hidden, is somewhere in the boundary between quantum mechanics and general relativity, where you can hide an awful lot of stuff.
Yeah. So that's why Ellis has his growing. He believes the wave function collapse in quantum mechanics is real, meaning that there isn't really any state of a system until it undergoes this thing called collapse. So the collapse of the wave function. So of all the possibilities, finally nature picks one, and then bang, that's the way things are. And so he thinks on that basis there must be a sort of there must be a fact about what wave functions are collapsing now. And so that's the front end of the universe in time.
Look, this is a really big question. I don't think we've really solved anything, but I think it's good to get across to people this notion that there isn't this single picture of what time is. No physicist can give you a single answer to that time is this thing. And I actually think that probably Tim Bedding's definition that time is a thing that physicists measure with a clock, probably about as good as it gets.